Good afternoon, everybody, and welcome to episode number 9 in our Trench Talk series of webinars. Our goal is to really share knowledge on the installation, design, and service of geothermal systems. So thank you all for joining us today. I'm particularly excited in this episode. We've got some panelists who I've come to respect for being leaders in our industry. And I appreciate their time to share their time with us. I also want to thank our sponsor this month, Source Rock Geothermal. They are a dedicated loop installing company targeting both vertical and horizontal ground loop installations in New York State. So if you're an HVAC contractor, want to get into geothermal, but you're hesitant because of the challenges of burying pipe in the ground, please give Source Rock a call or check out their website, and maybe they can help you. So today's agenda. First, we're going to lead off with a friend of mine, Amal Humsi. Amal and I go back to a period in time, I think, when dinosaurs roamed the earth. Amal and I worked at Carrier many years ago. So I appreciate Amal joining us today. He's now with Samsung, and we'll share the product line and some design software just to make sure we're all familiar with the products that Ryan Sarda from Dandelion will share some of his insights and experience applying the Samsung equipment. And after Ryan, Scott Adelsbach with Chicagoland Geothermal, and pay particular attention to Scott's presentation. He's got a very unique drilling operation, and many of you may find it intriguing and appealing. And then we'll spend some time maybe chatting amongst ourselves and general discussions, but more importantly, we want to have time at the end for some questions and answers. So please use the chat window to submit questions. I'll try to stay on top of them and bring them up at the appropriate time. So without further ado, I'm going to hand it off to my friend Amal, who is going to activate his screen sharing. And while he's doing that, I guess I want to share with you all the fact that when I started working on my first heat pump, which was quite a while ago, back in 1975, since then, the aspect ratio or the form factor of heat pumps haven't really changed. They fit where a furnace goes and connected ducted systems, but Samsung brings a whole new dimension to applying geothermal. So with that, I'll turn it over to you, Amal.
Thank you, John, and good afternoon, everyone. What I'm going to do today is give you a very, very brief overview of the Samsung product line, just to pique your interest. And if you need additional information, you can get back to Phoenix Energy Supply, and they will give you all the information that you require. Samsung has or the agenda that I'm going to cover today. I will give you a product overview. I'll talk about the operating range and the selection. I'll talk about the indoor units, and that's what John referred to. With Samsung indoor units, that gives you a lot of flexibility to do some applications that you might not be able to do otherwise. We talk about the general installation guidelines, refrigerant piping, and a brief overview of the water side controls. Samsung has two lines. We have a single phase line that is 3 tons, basically 4 and 5 tons, let's say. And each system, you can connect up to 9 indoor units, depending on the size of the unit. You can range from 6 to 9 units, depending on the size. And of course, you can use it with a typical cooling tower, or for the single phase. The majority of those units are used for geothermal applications. On the commercial side, the three-phase equipment, we have a line that goes up to 50 tons. Basically, we have individual modules, 6, 8, 10, 16, and 20-ton capacities. You can combine 3 of those in order to get up to 50 tons. Those units are available either in 208, 230, or 460 volts, and we have them either heat pump or heat recovery. It's the same unit, but you can configure it in the field to use it as a heat pump or a heat recovery. And by heat recovery, which you might not be familiar with that, in the VRF world, heat recovery means that you can be doing simultaneous heating and cooling at the same time. So you might have a space that requires cooling, another space that requires heating. With a heat recovery system, you will be able to do that. In terms of operating range, on the cooling side, we can go from 50 degrees entering water temperature to 113. And on the heating side, we can go from 14 to 113. We have a wide range. Of course, after certain temperatures, you need to use, antifreeze in order to accomplish that. And it is very important to adhere to the GPM or GPM range that is required for each unit. Nice thing about the VRF system is we have a selection software that will help you design the system. Basically, with the VRF and with water-cooled unit, there are some rules that you must adhere to. And once you use our selection software, at the end that everything is okay if you do not get any error messages. So it's kind of foolproof. You can go wild with design, and as long as you're within the parameters of the system, you will be okay. And if you're not okay, the program will let you know. In terms of indoor units, that's where the flexibility of the system lies. So basically, we have ducted and we have non-ducted equipment. And a lot of applications, like you might have older homes or historic buildings that do not have ductwork, and it's very difficult to install ductwork after the fact. So with the variety of ductless splits that Samsung offers, we make the job much easier. And one of the complaints that people get, with the ductless splits is air blowing on, the occupants in the space. So Samsung recently introduced what is called the wind-free technology on their ductless splits to avoid that. And the concept there is simple. So if you have a high wall system, when you start the system, basically the unit will blow the air like a typical unit until it reaches the set point. Once you reach the set point, the louver closes, and then the air is discharged around the front of the cover. And what Samsung has, we have on this particular unit, a high wall, we have 21,000 micro holes where the air diffuses through those holes. And when it discharges from those holes, then the velocity of the air that is leaving the unit is very low velocity, less than 1.5 meters per second, which per ASHRAE is standstill. So you're cooling the room, you are doing it at very low RPMs, you're saving energy, and you are giving even temperature everywhere in the space. And that's a typical example on like a one-way cassette. So basically the unit starts regularly until it reaches the set point, and then it will maintain the set point. But if you compare a traditional unit with a wind-free unit, so this is a conventional unit with 2 people at 5 feet and at 13 feet. And there is almost a delta of 10 degrees between what those 2 different people are feeling. While if you have a wind-free, because the air is mixing through convection in the space, there is only a 0.36 degrees difference between somebody standing at 5 feet and somebody standing at 13 feet. So you are providing comfort to your, to your customers. In terms of guidelines, Samsung requires only two things. The first thing that Samsung requires is a flow switch. So if there's no water flowing through the system, you are going to get an error message. And the other thing that Samsung requires is a 50 mesh strainer. Those are the only two. And then you can build the system, whatever you like, ball valves, cleaning ports, whatever you want. But the strainer and the flow switch, those are the two things that Samsung requires. The product is very flexible. In terms of the single phase units, the total piping length that you can have is almost 650 feet with an elevation of like 98 feet between, the roof and the lower unit. That's on the single phase. On the three phase, you can have up to 1,640 feet of total piping length and an elevation of like 195 feet. So it is very flexible. I don't think you will run into any applications where you require more than, those limits. And there are a lot of rules and regulations for the piping, but again, the selection software will figure those things out for you. And I haven't seen an application yet where, we ran into problems. The way we connect the units is you have the outdoor unit and then you have refrigerant piping. And we have wide joints that connect the different units to the outdoor unit, or you can use headers. So basically you get the refrigerant to either a 4-port or an 8-port header, and then you connect the units to those headers. That is on the heat pump system. If it is a heat recovery system, we have what is called a MCU, and basically that is a refrigerant traffic cop that basically decides which unit require heating, which unit require cooling, and it sends the appropriate, either hot gas or liquid for those particular units. And that's how you are able to heat and cool at the same time. In terms of the water side controls, again, we make it simple. Basically, if you want to control the water flow to the unit, you can have a two-way solenoid control valve. That is not required, but if you want to, you can do that, and you can control it. I mean, there's terminals on the board that will control that. Actually, you can wire it from our board too. So when the remote controller is on, then you close the contacts and then the valve will open. The other thing that you can do is you can interlock the pump with the system. So again, when the remote controller is on, the pump is activated. And then this is the flow switch, which is a requirement for Samsung. Again, you have terminals on the board to connect to the flow switch. And then what Samsung offers, that we offer refrigerant water flow. And we have the terminals on the board too. And basically it is controlled by 0 to 10 volts, actually 3 to 10 volts. And, we control the valve and the flow of the refrigerant. So this is a quick overview of, the Samsung offering. And then if you have any questions at the end, I can answer them for you. Thank you.
Well, thank you, Amal. That was fantastic. And we got Ryan Sarda coming up next. Let's see if we can transfer control. Ryan, you should have mouse control.
Let's test this out. All right. I think we're set. Okay, thanks, John. Well done, Amal. I think you made my job pretty easy here. I don't have to introduce the product at all, but I really was here to talk about the reasons why Dandelion chose to add it to our product offering, why we've ultimately decided to sell it to our customers and install in homes. It's mostly because of the flexibility, spoiler alert. And then also just take you through a couple of really quick design examples of homes that we've actually designed and installed here in New York. So first off, a little bit about Dandelion. We are a residential geothermal heat pump installer, primarily based in New York, but we operate in Hudson Valley, Long Island, Connecticut, and Mass. 90% of the business that we do is retrofit, which means we're dealing with existing buildings and we're dealing with the heating and cooling systems that are already in place. And we all know that there are challenges associated with trying to work with things that are already there and retrofit and convert people from fossil into a fully electrified heating and cooling solution. Another tidbit about Dandelion is our entire lead generation to sales conversion to final contract. The entire process is virtual. So anybody that comes into our system, we funnel them through our website. And then as they work their way through the process, we learn more and more about their home. So we have a pretty clear picture of what the home looks like so we can understand if we have a product that meets their needs. Our approach is entirely forced air heating and cooling. So we typically, before the VRF addition to our catalog, we typically only installed packaged or split equipment. But with all of these digital leads coming in and that entire survey process, we find that a very, very big percentage of the homes that enter our system are homes that are heated with boiler-fed baseboard radiators. And a lot of those homes either don't have ductwork and don't have AC at all, or they might have what we refer to as AC-only ductwork, potentially put in the home as an afterthought, meaning it was put in after the house was already up. It was sized to cover the air conditioning load for the home, which in this part of the world is about half the heating load, right? Much smaller, so much smaller airflow rates. And then also because it was put up after the fact, it doesn't necessarily cover the entire home. It might cover main rooms in the house, but not all of them. So that's an issue. That's a thing that you have to deal with. Just on Long Island alone, since July, 70% of the homes that come into our system fall into this same category. So obviously, a contractor like us only installing forced air heating and cooling solutions, we have to find some way to try to sell to these customers, get in their homes, and deliver a system that gives them both heating and cooling, right? There are ways to deal with existing baseboard radiators, maybe increase the size or change the style and try to serve those with a conventional standard temp water unit or something like that's available on the market. But in that approach, it's hard to deliver air conditioning as well. Customers that spend a bunch of money probably want both, right, on a premium system. So when we look at all of the product choices that are available in the marketplace, you try to pick one that checks most of the boxes. What gets you into the most homes and gives you the most straightforward way to install in those homes and deliver the heating and cooling that these customers are expecting. And then obviously when you're dealing with hydronics versus forced air, the question of dealing with hydronics, you try to balance what delivery temperatures can you effectively deliver to the home, send to your heating distribution system. And then as you're dealing with hydronic, baseboard, steam, some of those, they require hotter temperatures than you can typically provide with a standard water-to-water unit, right? So you're dealing with some sort of major renovation to either change that out or supplement with ductwork and all these things. As you know, in existing homes, that can be challenging, right? It can become a very big project, major renovation in the home, right? So given all the choices in the marketplace that are available, to try to answer, well, what's the best choice to serve the most customers in the most straightforward and standardizable way, we turn to a case study. My graphics aren't really showing through on my side. Can everyone see at least the picture and the bullets on the screen? Yeah, okay. So we looked at a home. It's up near Albany. You can see all the basic stats for it, right? Two-story home. This home is heated entirely with boiler-fed baseboard radiant, no air conditioning or no ductwork in the home whatsoever. They did have a couple of mini splits serving the bedrooms on the second floor, so they could sleep comfortably in the summertime. The basement mechanical room was under the basement was entirely open under the first floor, had plenty of access here. But you couldn't so you could install ductwork in the basement, but you couldn't easily get from basement to second floor to hit that part of the home, right? So this is a very common challenge that we see in our market out here in the Northeast. So we did the normal thing that we do with all of our homes, did a full-on virtual a 3D survey process, took scans of the home, got all the dimensions, the floor plan, understanding insulation and window quality and all those things. so that we could calculate the peak heating requirements of the building, as you can see, 42,000. And then also we measured all of the baseboard radiators throughout the house, understanding the type of radiator. You can also quantify how much heat you can get out of those radiators as a function of delivery temperature. So on the screen, you can obviously see take about 160-degree water to meet the heating needs of the building on the coldest day of the year. And then you can quickly see how that radiator output capability tails off pretty quickly with lower delivery temperatures through those radiators. So understanding that much about the home, next thing that we looked to do was evaluate a handful of equipment choices. So what can we look at here that would allow us to serve this home, heat or cool it in some way? We limited our study to 4 different pieces of equipment. One, the top one here, is a high temp water to water unit capable of giving you 160-degree water to the space, but it's a cascading refrigerant system, refrigeration circuit. So it can make the 160-degree water, but because it's 2 refrigerant circuits in series, it can only operate in one direction. It can only operate in heat. It can't deliver AC mode. So you kind of detect the point there, but we know with the 160, that's what we need to meet the heating needs of the building on the cold day. We also modeled the performance of a water furnace high temp unit capable of delivering 145, which doesn't get us quite all the way there with the existing radiators, but pretty close. But the nice thing about this unit is reversible. So you could find a way to deliver heating and cooling to the space, so long as you figured out the chilled water solution to some sort of forced air component, like a fan coil. And then the last 2 products that we looked at here, knowing that we couldn't easily install ductwork throughout the entire home, to serve it with one piece of unit, we looked at ductless products. So we compared, we looked at the Samsung DVMS water connected to a ground loop and modeled performance of that for the year. A full ductless approach with high wall units connected to a compressor in the basement and also connected to a ground loop. And then just to keep us grounded for sanity check on operating costs and efficiencies, we also compared against an air source unit. The Mitsubishi Hyperheat models, also full ductless, but the air source counterpart. After looking at the energy requirements for the home, there we go. Looking at the energy requirements for the home and understanding the equipment, how it perform as a function of weather and ground loop temperatures and all these things, you can model the performance of the system over the course of the year. You can predict how much energy we would be able to supply with the heat pump by itself versus what would need to be made up by supplemental, some sort of backup heat source through those radiators, knowing what we know about the house. And here you can see in this table, there's one very clear winner in terms of this home, being able to serve this home with a solution that delivers heating and cooling at a very high efficiency, actually. And also able to deliver 100% of the heat energy required for the home without any backup required. Also, I found it interesting that, keep in mind that Nordic heat pump that was able to make 160-degree water, meaning we would be able to meet the peak load of the building. The average COP value for that unit, because it's a lot of thermal lift for a heat pump to go from 30-degree source to 160-degree output temperature, the average COP of that was lower than the air source Mitsubishi unit for that home over the course of the year. So this study made the choice easy. We decided to add the Samsung DVMS water product to our offering. And obviously in doing that, now we're able to avoid the need to figure out how to deal with the existing hydronic system, the existing piping, the water quality in the system, trying to figure out how to run chilled water all over the place, which needs to be perfectly insulated. All of those challenges that come with hydronic piping, we're able to avoid by running refrigerant lines from the compressor in the basement to the high wall units that are scattered throughout the house. And with retrofits, when you have to get units, you have to connect something in the basement to something on the second floor. The really nice thing about refrigerant lines is you can route them outside. We always try to find interior chases, interior paths for our line sets to get from A to B whenever we can. It's not always possible. With refrigerant, you can always pop outside, up along the outside wall and pop back in and get to where you need to be. You'll always have that, that option, that choice. So given that, I just thought it would be helpful to go through a couple of examples of homes where we've designed and installed these systems here in our territory, and then I'll hand it off to Scott. So 3 examples here. Again, we deal entirely with the residential retrofits. This first example is a home up near Albany. This was a home that was heated entirely with a wood burning stove. And the bedrooms had some electric baseboard in them to make the difference, so they could close the doors at night and sleep comfortably, have a little privacy. No ductwork whatsoever, no existing AC. We proposed a full ductless approach here. You can see the color-coded floor plan. We proposed 4 high wall units in this house. This is a 4-ton system, might be a 5-ton system, compressor in the basement. Each of the indoor units in the bedrooms ranged between 9K BTU to 12K BTU. And then the one indoor unit in that larger common living, dining, kitchen area, that was a 2.5-ton high wall unit. This system's been in place for nearly a year now. It's performed really well. Husband and wife, the wife is really happy. She gets AC. She gets to sleep comfortably at night in the summertime when it's hot out. And the husband has to find a way to get some exercise. He's not needing to chop wood anymore to heat them in the winter. So there's a full ductless approach. Here's an example that to me speaks to the flexibility of these systems. This was a home that was heated with a boiler again and radiators throughout. They did have AC only ductwork that served the above grade floors. That was actually okay and we were able to use. However, in addition to that, they had some space in the basement that was finished living area that they wanted to be conditioned as well. And we couldn't easily tie that into the existing duct system. So what we ended up installing here was basically a system that consisted of a single air handler serving the above grade floors, so delivering all the heating and cooling to that part of the home. And then you can see on screen 2 high wall units, one for the rec room and one for this bedroom down here, heating and cooling through the entire home, forced air, without having to do a major renovation to try to tie into that existing ductwork. And then example number 3 here, this is a nice application for VRF as well, in that this was a home that has 2 different systems, forced air on main floor and basement, and then also a separate system on second floor. The entire load for this home was less than 5 tons. So we could easily cover the load with a single compressor unit. And then basically what we did is we tied that to 2 separate air handlers, one in the attic for the second floor, one in the basement for the first floor and in the rest of the house. In the old days before VRF, this would have had to been a package unit for that in the basement serving that main floor, and then a split unit up to the second floor ductwork serving that part of the home. The fact that we were able to condense this to a single heat pump application served by 2 air handlers, we were able to reduce costs somewhat for this customer. And this was a Westchester home here in New York. And hopefully with all of that, you guys get a feel for why we decided to add VRF to the offering and some of the applications where we've actually used them, installed them successfully here in a handful of homes. Thank you.
Thank you very much, Ryan. That was fantastic.
My name is Scott Adelsbach. I'm locally in Chicago from Chicagoland Geothermal. We are a full turnkey geothermal installer. We do both commercial and residential. I've been working with Samsung's product for about 7 years at this point. First was actually there's an image on the up the screen as of right now, and that is the first rendition of the machine that I developed a couple of years before this picture. That is the way we drill our commercial and our residential systems. We have 3 of these going at this point, and we're building 5 more for ourselves because of what we're seeing as going to be a huge rush in demand by next spring is when I'm scheduled to hopefully get these things up and running, but I'm sure it'll be one at a time at that point. So this is in the bottom of a building. We use, this is the first time we used the VRF system. And this is called Cardinal Square Apartments. It's in Northern Illinois, pretty close to the Wisconsin border. If you can change the slide.
I see you're moving the mouse. Try your mouse button to see if it'll advance. There you go.
Oh, okay.
Oop.
Whoops, I went too far.
Yeah, let me back it up for you. I think.
I was swiping. Okay, that's the building, 65 unit building. It is it's 64 tons of heating and cooling. We drilled that right in the basement. If you can scan one more page. That is the system. That's the Samsung's VRF. This is only a heat pump. As you can see, that there's a unconnected port, pipe port on the refrigerant lines. But these 4 units are taking place of everything that otherwise would be up on the rooftop. But everybody here is probably a geothermal experienced person, which understands that. So it's probably not impressive to you. But in this situation, these 4 16-ton units, each one of them is connected to about 20 different air handlers approximately throughout the building. Each air handler, essentially, each thermostat in each unit contacts this unit, and this unit will just basically use its variable speed compressor and send refrigerant to whichever air handler is calling. Can you change the slide? I can probably do it from here on. There's the rooftop of that building, ready for solar. We are actually now doing a building. We did this building about 6 years ago, and it's been a complete success. The owners are thrilled with their energy bills, as well as their maintenance costs. We are now doing 2 more 90-unit buildings right next door, and you'll see some slides later. This is that's me. I'm sorry, I'm showing you there, or you're seeing me there. But what you're seeing here is probably unusual. If you're seeing this is a train at one point was rebranding Samsung's units. This is in the city of Chicago, right on Milwaukee Avenue, pretty close to the loop. This is an example. We drilled a loop field in this basement. There's again early rendition of our drill rig. If you look at the pipe to the left of me, we were putting piles in for the elevator about 65 feet down. So just another example of what we can do with this machine. But this whole building was 20-something thousand square feet, and we have 3 Geo units, VRF, which are actually Samsung's, shown in the background. It's probably not in good order, but this is another building. I just want to kind of show you this building it's an 18-unit building in down. There's 2 blocks from Wrigley Field. We drill in this case during construction of the building. We use the structure above us as downforce, as you can see in this building or in this photo. Okay, these are out of order, but I'll explain why. This is just an example of one of the single phase units that we installed in a residential buildings to the south side of Chicago. There's our loop field. It's a little dusty. We're not completely finished with this project in this photo, but this is what's unique about this system, the Samsung single phase system, is we have 8 different air handlers connected throughout this building. And we have, and they're all cassettes in this case, but it's a 3-story residential building. And in this situation, this is sending refrigerant to all 8 different air handlers. That's unique. This is an example of our loop field. When we're drilling underneath the building, we have exposed manifold right next to our equipment. I'm going to change from there. Okay, this is the previous slide you saw with the person drilling and the machine pushing up against the structure. This is the equipment location, 3 10-ton Samsung VRF units. You can see we also have preheated our domestic hot water on the left. You can see a water furnace. I think it's just a 3-ton unit that's preheating this building. This is also a A restaurant is on the first floor of this building, but the entire structure is heated and cooled with what you're seeing in this picture. Our loop field, again, is, you can see our connections, our manifold is actually right to the left of the 3 Samsung units. In this case, I believe each unit's connected about 6 different air handlers. That's the front of the building. It's a new construction, but we actually drill during construction, which is unique, and it opens up the door for a lot more geothermal installs, therefore, not being delayed for waiting for a driller to drill before they can start construction. We actually do it during construction. And yes, I'm kind of tagging my machine here a bit during this Zoom call, but I figure it might be interesting to some people. Here is an auto dealership. This is out in St. Charles, Illinois, which is 35 miles, actually about 40 miles straight west of Chicago. This was an old convention center that is being turned into a McGrath Honda. You can see 2 machines here. We swapped out with a brand new machine, the smaller one to the left, during this project. But in this case, this does have a Samsung system in it, and I'll show you that shortly. But we're putting 96 holes in the existing concrete floor of the convention center. Afterwards, we trenched out most of the slab was removed, and we installed radiant throughout. Another picture of the same. In this case, real quickly, we were not allowed to drill through bedrock. St. Charles, Illinois has its own well, so they will not allow any bedrock penetration. So we actually stopped at bedrock, and that's why we have so many holes. We're only 75 feet deep in each, but we do 4 in series, and they're all 1-inch lines, and then we'll have 6. We now have 6 manifolds that are actually accessible in the floor that connects all of this. Now this is just another example of a single phase units in the city. This is actually in a little coach house in the alleyway. I'll show you a cute little picture of the home shortly, but just an example of what you can do and how little space it actually takes to put this unit. It's a very small home, very small garage, and we were able to leave it up above near the ceiling to allow for something. In this case, they have bicycles stored underneath it. But okay, this is I'm jumping around a little bit. So this is another building that we're doing now. This is example of our drilling operation in the bottom of 2 90-unit buildings. This will have a simultaneous system. This will be going for about another year. We're almost complete with the first building of the 290. I'll get some better pictures that after this, but this here is that little coach house in the alley. Just a quick example of what it looks like. I thought it was interesting for people to see. But that's all. That has just 2 air handlers, one up on the 3rd floor and one in the 1st floor that are both connected to that previous Samsung unit that you saw that was elevated. Just another example of the drill rig and the way it works. As you see, we use the structure above as downforce. The system is 100% electric driven. We tie right into the electric panel. We can do single phase, we can do 3 phase. We only need 60 amps of power minimum to drill effectively. Okay, here's this is the example of what we're putting in. This is one of the 2 90-unit buildings. This will be these 2 there's 5 stacks. I'm sorry, 5 stacks of 2. And each set goes to approximately 30 different air handlers through an MCU, and there'll be 5 stacked MCUs throughout the building, or 4 stacks of 5, I should say. But in this case, in this building, you can't see, it's not a very good example because they gave us a really small space to work with when it comes to our mechanical space. But these 2 buildings will actually be 100% heated and cooled using geothermal as a source, using a loop field underneath. And we'll also be heating a pool. We'll be heating all their domestic water 100%, as well as their radiant and ice melt. Okay, there's the dealership now that we're doing. We're actually designing, and we'll be doing a Kia right next door, same size building. They're thrilled with the system, and we have a good shot of, okay, we're jumping back and forth there, apologize. But this is the 180 unit building we're currently, and this is what its current state is. And this unit, these buildings will be fully solar, I'm sorry, they'll have solar on the roofs themselves as well. Okay, this is the dealership itself, what it looks like now. This is the almost finished product. These are 5 10-ton Samsung. 3 of them, I believe, are simultaneous, and 2 are heat pump. So because of the situation throughout the building, there's offices, and there's shop floors as well as sales floor. It all determines what we decide to do simultaneous versus just heat pump alone. This is my loop field that you see. These are my interconnecting manifold points inside the building. This is actually on the 2nd floor, but you can kind of see a very simplified way of hooking up 50 tons plus an additional, you can't see it here, but there's an additional 24 tons of water to water for this building. The entire dealership is radiant, heated through water to water as well. So it's redundancy on the systems, but that's what the owner wanted. And there's a couple of water furnace water to waters underneath, as well as the hydronics behind. It's opened the door basically without me having the ability to do these projects, as in the knowledge on the Samsung VRF. I wouldn't sell these projects. I think it's a game changer when you approach an owner and explain what you can do for them versus having either a conventional system or have there's advantages to package and split units, and then there's advantages to VRF units. I personally find it to be a little less expensive in labor to do VRF versus the water system throughout, as in package units throughout. But opinions may vary.
Oh, my good friend John Shavako said, "What's with the beauty camera?" Well, I'll handle that question. John, we're not all as good looking as you, so we need the help of a beauty camera. So thanks for the question. Steve Cooper asked, does Samsung VRF offer potable hot water heating option? And Amal, I'll turn that one over to you. You got to unmute. There you go.
No, we don't.
When can we expect it?
That's a good question. Actually, that product is available in Europe, but I mean, right now we do not have any. I mean, we're looking into it, but we do not have a definite timeline.
Okay, well, thank you. I want to check on John Shavako. What's the possibility of meeting domestic content standards through the IRA provisions? And obviously the product is made in Korea, and I am not an expert on the domestic content details. I would be surprised if it did meet the intent of that made in USA.
Not, John.
Pardon me, Amal?
It doesn't.
It doesn't. Yeah, certainly as an equipment, but I look broadly at geothermal, and there's a certain percentage of the installed cost that, you know, maybe the equipment only represents 25% or some number that may comply, but I'm like I said, I'm no expert on what these rules might end up being, or even if they're defined yet. So certainly the equipment doesn't meet it. But it's hard to outsource drilling. One other question here. What would be the difference in installation costs between geo and air to air? I don't know, Ryan, I'll turn to you on that one. As far as when you looked at comparing to the Mitsubishi, I noticed you had two Mitsubishis. And I don't know if you looked at installed cost in your analysis, but what do you think?
We obviously did look at install costs. I don't have a lot of data points to speak to, right? But in terms of the cost for the interior equipment, very comparable, right? We're talking about essentially about this, similar form factor on the indoor units, similar form factor on the compressor unit, although installed inside versus hung on the wall outside. So that's very, very similar. The thing that's obviously different is the need for the ground loop, which is an added cost, but you get a whole lot more, rebate and incentive money, which offsets that. So anything that we compared very early on when we were determining what direction we wanted to go, the geo versus air source is like very similar. I want to say on the order maybe 10% difference in terms of total cost on the small number of quotes that I looked at. But obviously you get that money back in much higher performance over time.
Yeah, I agree. And when you get into these more challenging homes, it's hard to say which one's more cost effective. It's what is the base case? What are you going to do to deliver equivalent performance? And you get into these hydronically heated homes that you simply can't interface with. And if you tried to do it, it could get very expensive by upgrading radiators and just a lot of extra work. So I think the cost comparison, I just think generally it's comparable. So
I'd agree with that. Yeah, the alternatives in trying to deal with the existing hydronic system, it's very invasive, very extensive renovation project just to be able to convert.
Yep. I got a question from our friend out in Indiana, Tom Wire. Is the Samsung equipment eligible for tax credits? Ryan, you want to comment on your success at qualifying for rebates and tax credits?
Most definitely is eligible. Yep. And our policy team, I believe I saw Heather on here and Doug done really great work in getting the utilities to extend their rebate programs as well. So able to get all federal and local utility incentives, everything in everything that we've installed. Yeah. It's a geo unit, right? So all incentives that are available for any other geo unit, they certainly should be eligible, available to VRF.
Yeah, certainly one of the requirements for the tax credit was the Energy Star Tier 3 compliance. Have you seen that issue pop up at all?
Yeah. And that's the magic that our policy team had to work to get the VRF equipment recognized under the utility program here. Because the water source VRF is a little bit of a unique product, there is no real testing standard that's equivalent to the ARI standard that we're used to for forced air and water equipment to determine Energy Star eligibility. That said, it is it's an inverter driven variable speed compressor, a high performing unit. So there's no reason that we shouldn't consider it to be as good as Energy Star. There just isn't a formal standard that they can test to. So had to make kind of some custom exceptions to be able to build it into rebate programs, but able to do it. And now it's treated just like the rest.
Well, I applaud your policy team there, because
They're great.
I have no patience to deal with policy. I'm glad somebody does.
Yeah, we made great progress there.
Scott's on another note. He's still trying, but I've got another question. Our good friend at Nigeo, Bill Nowak, running refrigerant line outside. Why not concerned about maintaining temperature in the line?
Definitely.
You want to try that one, Ryan?
Sure. I mean, we're definitely concerned about it, and we insulate the lines when we install it, right? But the key difference is you don't have to worry about it freezing when you run outside. You're going to want to insulate anything that goes outside, but if it isn't absolutely perfect and you lose a little bit of performance in a line set, it's not catastrophic like a frozen line would be, right? And keep in mind that when you're talking about refrigerant lines, you know, the amount of exposed surface area in a 1/4 inch liquid line is very, very small, right? We're talking about small surface areas, small potential for heat loss anyway, and then the refrigerant velocity is pretty high. So there isn't all that much opportunity when the system's running for a whole lot of loss. That said, you still do want to protect against it by insulating the lines. Hopefully that makes sense.
Yeah, I certainly agree with your desire to run them indoors if you can. Obviously, I presume you use some sort of line hide to make it look aesthetically almost acceptable on the outside of the house.
Yeah, I mean, the reason for running them inside, obviously, it avoids the performance concerns and it's so much faster. A line hide is about the best you can do to make it look okay outside the home. It's very labor intensive to put that up.
Yeah,
especially when it run into stucco and brick and all these other things. It can be hard to put that stuff on. It takes a lot of time.
Yep. Very good. Let's see, John Chivacco, can standard flow centers be used? If so, how are they controlled? Yeah, I think there's a variety of ways to flow through these units, but Ryan, I'm interested in how you approach the pumping side in a residential application.
Yeah, we've tried both variable speed and fixed speed. Both you need provisions for either control and low voltage supply for the variable speed. And for standard pumps, you know, it's just on off, but you have to control that with a low voltage relay into the board. We have switched entirely to on off, just standard flow centers and on off control with that low voltage relay. Partnered with Tom at GeoFlow for some of that stuff, and it works pretty well. You know, in looking at how the Samsung units work, obviously you would ask if variable speed control is possible. Why wouldn't you try to take advantage of savings in terms of pump energy, especially when running in heating mode? The small residential units, at least, they don't vary the speed all that much as it from what I've seen anyway. So the simplicity and the lower cost of fixed speed pumps is just what we opted to run with for our installs. So long-winded way of saying, yeah, you can use a standard flow center.
I've been extremely impressed with the Samsung product and what it's done for me. For business in general, it's just opened the door for a lot of things that otherwise I personally, not having the, you know, if I didn't have this knowledge that most people don't have, number one, you know, we wouldn't have sold these projects, and these projects would have not done a geothermal system. They would have just gone conventional. So it's a nice edge to have, and now we're involved with many more planning many more of similar buildings throughout Chicago.
Well, thank you, Scott. I know we chatted a little bit about the distributor that you buy from and the great support you got from them. How would you characterize Samsung as far as supporting products? And
you know, it was a little edgy in the beginning, or a little it was difficult, but I was also I think I was in like those 16-ton units you saw in the first building I put in. At that point, Samsung really didn't develop a tech support system. The 16 tons were the first ones that were actually introduced to the US at the time. Since then, things have come a long way. And but all along, I do feel that the Samsung product has been pretty, you know, top notch when it comes to quality. We have had a couple small things happen with circuit boards But outside of that, I've been very happy with we install a system, and I'm not someone that really enjoys servicing. And they're we're not going back, and that's pretty extraordinary. The one I did in Wrigley Field 3 years ago, right next to Wrigley, they're actually planning a building. We're going to start one this spring for the same person, but I have not heard from them. So I'm always concerned that did they find someone else, or but no, it's just we started up, and that's a simultaneous system that's run well ever since.
Yeah, Amal, maybe you can speak to the history of Samsung in North America and the transition it's gone through. I wasn't a part of the early days, but everything I've seen since then, it's a remarkable company to do business with.
Yeah, and I've actually been really impressed with what's happened with them since COVID and with shortages. Yes, their pricing has gone up, but I would have to tell you minimally versus the others. And turnover time is still, we're ordering 90, another 90 unit building as of right now. And there's still the turnover time is pretty amazing.
Yeah, certainly the supply chain challenges were hit Samsung, but they navigated them well. And frankly, for the three major products we carry, the Samsung is the shortest lead time product we deal with, which says a lot about Samsung's commitment to inventory and having product down in their warehouse down in Texas. And typically we can get equipment within a couple of weeks is pretty routine. So I'm gonna, anybody else, Ryan or Amal, you got any last thoughts now that you've heard from the other folks?
It looks like you have one more question, and I think I can speak to. It's what suggestions would you have for a first install or complications to avoid? Probably the thing that I would say is there's a bit of a learning curve with, especially on the first one or two that you install. Samsung's got a lot of great training content. I would encourage anybody who's looking to get into this to run through that. Take your time and go through that. And then also, we probably wouldn't have done as well as we did without the support from Phoenix Energy. I mean, John and Jared, you guys have done a great job of pulling together quick reference guides, startup guides, and all that kind of stuff. Really wading through all the pages and pages of tech info that you have and install manuals and really pulling out the important things. That was helpful as well. But learn what you can about the systems before you try them out. That's what my advice would be.
Yeah, no, I got to give all the credit to Jared. I'm too old to learn this new stuff. So Jared's, I'm sure, listening in. So I give him all the credit.
Hats off to him. It's been helpful.
Okay, we get another one. Tom, Ted Mills has a question under the Q&A link. Okay. Oh yeah, there are a couple there. Ted, how does the COP vary with colder loop temperatures? I'm thinking of cold lake loop applications where entering loop water temperatures can be somewhat below freezing for a good part of the winter. Canadian lakes covered in ice. I'd certainly like to say that all the pond loop applications that I've been involved with, once they freeze, they actually get warmer. It's right up to the point of freezing. Do the water temperatures really drop down to approaching freezing? And then of course your closed loop inside the pond might come back a good 5, 6, 7 degrees colder. So they can get pretty cold, but once it freezes and really shuts off the evaporative cooling, you might see about 38, 39 degrees in the pond because that's the densest water and it settles to the bottom. So as far as COPs, I mean, the nominal rating on these things at 30, 32 degrees is what you typically design around. Ryan, I don't know how closely you've looked at COPs as a function of water temperature, but their expanded tables in the Samsung books are extremely detailed. And you can examine at different water temperatures, different indoor air temperatures, different flow rates. So you can see all that kind of data to really get a handle on how well it's going to perform. So
That's right. That's what I was going to suggest. I'm sure Amal could send the performance tables. It's all available.
Yep. And I want to thank Ryan also for getting it set up. I think you guys did the loop link and loaded all that data into loop link, so at least we can satisfy the utility gatekeepers and give them a loop link printout.
Yeah, that's right. And we use it as well. Size the system and get the rebate for sure.
Yep. I do want to encourage you all to fill out our short little evaluation poll. I appreciate everybody's time today, and we've certainly gone over our hour target, but I think it was very informative, and I want to thank Brian and Amal and Scott for sharing their time with us. So thank you very much, and we'll see you all next month, I hope.